Okay, in these series of videos we're going to learn about Pythagoras' theorem and how it is used. Now if you have any right-angled triangle, and you can tell a right angle by the how it's drawn, and if there's a little square box in here, that is the right angle, and the side opposite the right angle is always called the hypotenuse. So that is always the longest side. Now, if we drew a square on each of those sides, let's call that side A, that side B, and that side C. Okay, so if I drew a square of length C on that side, C length, C length, C length, and all of those are C, then the area of that is C squared. Here's a square on the B side. All of those are side B. The area of that is B squared. And similarly, if we draw a square on the side A, the area of the square will be A squared, because it's all the sides are of length A. Now, if a square is drawn on each of the three sides, then the area of the biggest square, now that's the biggest square, is C squared, is exactly the same as the areas of the other two added together. So if I cut A squared out and B squared out, I could fit them exactly into C squared, and I'm sure you did this in class. So C squared equals A squared plus B squared, and that is our Pythagoras' theorem, and it occurs in any right-angled triangle. Okay, so once again, if this is side A, side B, and the longest side is side C, if we know the lengths of two sides, we can find the length of the third side using the theorem. And the theorem, you can write it as C squared equals A squared plus B squared, or you can turn it around and write it as A squared plus B squared equals C squared, depending on whether you're finding the hypotenuse, put it around that way, and if you're finding one of the shorter sides, have your formula around the other way. So it's very useful when you know two sides that you can find the third side. So let's first of all find the length of the hypotenuse. So here we've got our triangle, right-angled triangle, A, B, and C. And now let's put some numbers on here. Let's say that A is 4 centimeters long, B is 3 centimeters long, and we have to find C. So we'll call that X. Now because we're finding the length of the hypotenuse, we're going to use the formula around this way. C squared equals A squared plus B squared, and this is how we set it out. X squared, that's our unknown on the left. X squared equals 4 squared plus 3 squared. Now we just want to find out what X is, so we don't go use our calculators until we rearrange it. If you take the square root of both sides, you end up with X equals the square root of 4 squared plus 3 squared. Now depending on which calculator you've got, if you've got a new calculator you don't need to put a bracket, but with the old calculators make sure you put a bracket around the 4 squared and the 3 squared. Now you go to your calculator, key it in, and you'll find that X is equal to 5. And of course we put centimeters. Now this is one of a combination of numbers that work out evenly. We have no decimal points in the answer. And these ones that work out evenly are called Pythagorean triples, or triples. And this particular one that works out is called a 3, 4, 5 triangle. And any multiple of 3, 4, 5 works as well. Now let's use some decimals, and we'll put some different numbers in. 28.3, 15.8, we'll call it meters this time, and we need to find x. So let's use Pythagoras again, Pythagoras' theorem again. X squared equals 15.8 squared plus 28.3 squared. X is the square root of, and I'm going to put brackets in case you've got an old calculator, plus 28.3 squared, and if you do it on your calculator you get 32.44118. Now we want to round to 1 dp because there's 1 dp in the question, so you really can't have it any more than 1 dp. So if you put your 32.4 meters, 1 dp, it shows you've rounded it, and that gives us the longest side. Now always make sure and see if your answer is sensible. 32, it has to be greater than 28.3 and near that answer. So if you've got something that's not sensible, do it again. Now in the next video we'll use Pythagoras to find one of the short sides.